In a prior video, I did a 4-relay dump controller for heating purposes from a wind turbine, and that person has asked me how he can measure the voltage of the wind turbine and feed that into the micro. And so this is what I came up with. It's basically a full wave rectifier going into a PC817. That's an Opto isolator. There's 2 resistors to provide isolation and voltage drop, and the output of this Opto isolator is basically just a transistor, and that transistor goes into a resistor signified by this pot, and you adjust that till you get about 2.5 volts on the voltage that you normally think you're going to be seeing. So if he's normally expecting only about 120 volts, you'd set this between 2 and 2.5 volts. Right now we have it set for 250. It's at 141 volts, and it's not clipping. I don't know if you can see this. I'll show it better later. But this little blue line here is 4.4 volts, and once you get up to 5 volts, this waveform is going to flat top, and it'll be more non-linear than it already is. This is a fairly simple circuit. The one really nice thing about this is it provides electrical isolation between the micro and the wind turbine. And we know the wind turbines are out there in a big tower, and what do they attract? Lightning. So this provides some protection. If I had this in my system, I would put a couple MOVs to ground right here. This will give you isolation of around 3,000 volts, but good lightning surge will be higher than that, so a little extra MOV protection would be a good idea. So here we can see 141 volts, and it's 2.5 volts going out. We drop down to 120, and it's 2 volts. 110, it's 155. About 80, it's 1.14, and so much. Now, these are not extremely linear, but it's cheap and dirty, and generally within a short region, it's fairly linear enough. Everyone today wants 5 digits of accuracy. You don't really need any more than 2 digits for most things. This is going into a program where it's just looking at the number of counts, and you can easily transfer that into voltage with a map function for a short region. It's fairly linear. But let's look here. I don't know if you can see this well, but you can see the waveform right here. Now the reason we want to adjust this is, see, there's low, and as we keep turning this up with higher resistance, you'll see it flat top. Of course, when you saturate that wave, you're not going to get any linearity, so we want to back down to, as I said, it'll average out about 2.5 volts, and that's a good setting for this. Let's pull some of this out of here and we'll look at this circuit. So what I have currently is a single phase, and that goes into a little bridge rectifier, 22K on each side. I like to put these right at the connector, so this acts as a fuse, so the line going to your control system, you can use small wire, don't have to worry about fuses. If something shorts out here, it's not going to be disastrous. So I like to put them, your 3-phase is all your points are generally live on it. So this provides a nice isolation. Here's the PC817. They have a transfer ratio from about 30% to 300%. You never know what you're going to get. That's why you have to have an adjustable pot. This particular one I have in the circuit is close to 300%. And I bought them guaranteed 200 minimum, so this one's about 280% transfer. So you're gonna have one of the inaccuracies you're gonna have is this is around a volt, and you get around a 2-volt drop here, so already you're subtracting some voltage. This is a DC waveform, but it pulses. A 10K resistor and a 4.7 microfarad capacitor. That'll average out, and you'll have a nice DC reading for your microprocessor. Now, if you have 3-phase, you can have the A, B, and C phase each feed into their own rectifiers, and this goes to the Opto isolator. You can use IN 4007s. You can use practically anything, because these diodes will never see much voltage because they're down. They'll never see a reverse voltage of more than 5 or 6 volts. So each of these resistors, because it's 3-phase and you get a little more current, we bumped this up to 33K. This just gives you an idea of what you might expect in a 120 volt system. The resistors adjust up and down. Mostly I'm looking for around 2 to 3 milliamps going into the LED. That works good. Again, with the transfer ratio, if it's 30%, this resistance is going to be higher, probably up around 2K. With my this particular 300% one, I'm around 400 ohms. So if you do this, it might be a good idea to find out what this resistance is, and then use a fixed resistor. Sometimes pots will get a little noisy. You know, most wind turbine applications, solar things, they're out in the environment, they're out in the garage, they'll collect moisture. So getting rid of the pot after you've figured out what your each one of the PC817s is a good idea. Again, this is what I measured with my unit, 140 volts, 2.75. So as you go down, you know, the accuracy leaves you, but between, you know, short regions, it's not bad. And most applications, you just need an idea of what you're doing. This works nice for generators, even batteries. You can cal it up in your system. Again, an ARDUINO has a map function, and you can straighten this out a little bit. I don't think it really matters. This is a dump load application, so anything close is going to work. So thanks for watching, and hope you found this interesting.